This is the video recording for homework 8, problem 1. The problem setting is given that xt is a White-Sand stationary process with its means value E of xt equal to eta, which is a constant, and the correlation function is Rx of t1 and t2, where tau is equal to t1 minus t2, and we suppose yt is equal to the first derivative of xt, and so we need to find out several values based on the information we're given. The first problem is to find E of yt, and as we know that yt is equal to the first derivative of xt, and we can rewrite this equation where we need to find the E of yt equal to E of xt to the first derivative, and then we can rewrite this to the outside of the bracket to be the differential of E of xt, which is as we know, this part is essentially eta, which is a constant, so the value of E of yt is exactly equal to 0. And as we know from the problem, R of t1 and Rx of t1 and then t2, and is exactly equal to R of tau, where tau is a constant and is equal to t1 minus t2. So if we suppose in the equation of in the relation function where t1 is equal to t2, we can write it as and if we also take the differential on both sides, we can get that the differential of RT1 and T2, where T1 and T2 are exactly equal, we can get it to be this function, this equation, where it is, as we know, the RT is equal to RT and T1 and T2, where T1 and T2 are equal, is equal to the E of xt times xt. And we take the differential of this equation, and since the inner side of the bracket is xt to the degree of 2, we can get it to be exactly equal to 2 times the means of xt times xt to the first derivative. This is basically employing the rule when we are finding the derivative of a complex function, and as we know, this is equal to 0 actually, because both parts where both parts of ext and ext to the first derivative are independent, and the second part is the E of xt to the first derivative is equal to 0. So when these two are timed together, the product is exactly 0, and we can get that the E of xt times yt is exactly equal to 0. For the third question, we need to prove that xt and yt are uncorrelated, because we know that ext times E of yt is equal to 0, and it's also equal to E of xt times yt. This equation proves that xt and yt are uncorrelated. And xt and yt for the first question are also orthogonal, because, as we know from the equation above, E of xt times yt is equal to 0. This is exactly the definition of orthogonal for two different from two different events or functions. So this is the end of this video record.